when you see this kind of language where we have, something is 20% more than something else, it's a good idea to just set up a ratio. So you would say, something is 120 to 100. And something is 20% more than something else. And then I would recommend reducing to the smallest numbers that fit that ratio. So we would reduce there by a common factor of 20. And then we would give them titles. So what was greater than what? The first thing was the ones that went up. So the stocks that went up versus the stocks that went down is a ratio of 6 to 5. One thing we could say now is that there are 6/5 as many stocks that went up as there are that went down. We could also say there are 5/6 as many stocks that went down as went up. So fewer stocks went down than up, 5/6 as many. And I think that it's a really good habit when you see the word percent to translate that into a ratio, because that's going to be a lot easier to work with. It's also a more intuitive way to think about percent change. So something is 20% more than something else, I prefer to translate that into it's 6/5 as many. It's a ratio of 6 to 5. And the way we did that again was we picked 100 for our benchmark. So the starting point was 100, and then the other one is 20% more than that. So we have 120 to 100, and then we reduce to the smallest integers that fit. Exactly. So the stocks that went up from yesterday is the 6, and the stocks that went down from yesterday is the 5. Now, they told us something in the very first sentence. They said that all of the stocks closed at a different price today compared to yesterday. That means they all either went up or down. None of them stayed the same. Well, that means that our ratio of 6 to 5 captures all of them, all of the stocks. There aren't any other stocks that weren't in this group. So it might make sense at this point to say, well, if the ones that went up are 6 ratio units and the ones that went down are 5 ratio units, then together there's a total of 11 ratio units. So now for the first time we're making an inference in the world of ratios. We're saying in that world of ratios, the total number of stocks is 11 ratio units. And we'll see later today in some very hard data sufficiency questions that getting into the habit of making such inferences, right, where we add 2 columns to get a third one, like we did here, or subtracting 1 column from the other to get a third one, those kinds of inferences are tested a lot, particularly in data sufficiency. We'll see that today. That's right. And we actually wouldn't be able to solve this question without knowing that all 2,420 stocks changed. And now with our inference column for the ratio, we can say really advanced things like of all of the stocks, 6/11 went up and 5/11 went down. So to get to that kind of inference just from this sentence here with a 20% greater is impossible, I think. Without drawing the ratio and making that inference column, I don't know how you go directly from a sentence talking about some stocks being 20% more than the others to 6/11 of the stocks went up and 5/11 went down. Now they want to know how many of the stocks went up out of the 2,420. And I want to show you the answer choices here. So with our ratio, where we can see that 6/11 went up out of 2,420, do you need to do any math now, or would you say there's only one answer choice that makes sense? That's exactly right. We know from the ratio that the correct answer should be just a little bit more than half of 2,420. Half of 2,420 would be 1,210, right? 1,210. So we're looking for an answer that's a bit more than that. And so that eliminates A, B, C, and E looks a bit too high. Now, if we're not sure between D and E, there's another trick we can use here thanks to our ratio. You see, with stocks, we have an integer constraint. The number of stocks can't be some fraction. So the correct answer has to be a multiple of 6, because that's what we're solving for. It has to be some multiple of 6. Now, how do we test whether a number is a multiple of 6? We have to meet two conditions. It has to be even, and it has to be divisible by 3. That's right. And how do we know if a number is divisible by 3? We add the digits. If the sum of the digits is divisible by 3, then the number is divisible by 3. So answer choice E is even, but 1 plus 6 plus 9 plus 4 is 20, which is not divisible by 3. So we could actually eliminate E and C and A for that reasoning. A, C, E are not divisible by 3. Just add the digits and you can see that. And so then you're down to B and D, and B is less than half, D is more than half, so it has to be D. Now you might wonder, well, what if the answer choices were different? What if all the answer choices were multiples of 6 and were pretty close to each other? Well, then it wouldn't be a GMAT question, because then you'd actually have to do the math. And the whole point of a GMAT question is you shouldn't need to do the math. So we used two tricks here. One was, both tricks were based on the ratio. So trick 1 based on the ratio was just to kind of see out of the total number of stocks what fraction we're looking for. So we did that by translating the percent into a ratio and made an inference within the ratio. And then the second trick was to use the integer constraint with the ratio to infer that the correct answer has to be a multiple of 6. What does need to be a multiple of 11?
The total.
Yeah, 2420 must be a multiple of 11 because of the integer constraint. Now, for people watching this on YouTube, I'll link in the description to a video where I explain the integer constraint principle for ratios. I'll also link to the video where I talk about divisibility by 3, where I explain why adding the digits is the way to figure that out. I think there's an important takeaway from this question, and we're actually going to use that takeaway for the rest of the day. The takeaway is that any percent difference really should be thought of as a ratio. So in this case, we said something is 20% more than something, and we decided to think of it as a ratio of 6 to 5, a ratio of 6/5. So if you know the ratio of two things, you can infer the percent difference. And if you know the percent difference, you can infer the ratio of those two things. Those are really kind of interchangeable. And I think the common mistake people make with a percent change is they think of it as something additive. They even say it. They say, I'm adding 20%. But you're not actually adding. You're multiplying by 6/5. You're multiplying by 1.2, if that makes more sense for people. When you're subtracting 20%, you're not actually subtracting. You're multiplying by 4/5 or 0.8. And why is that so important? Well, as I explained in the video I did for GMAT Club, and I guess I'll link to that in the description as well, additive operations on the number line don't care about where 0 is. And they're just going to move you a very predictable quantity to the right or to the left, regardless of where you are in the number line. Multiplicative operations, on the other hand, their impact absolutely depends on where you are relative to 0, because they operate on your distance from 0, and that's a very different kind of operation. So we need to understand that percent change is a multiplicative operation, not an additive operation. We'll see how that comes into play in the next few questions that we look at. That's right. But it's more than that. It's also the how much will you move, right? The farther away from 0 you are, the more movement multiplicative operation will result in. So for example, 100 times 2 moves 100 units to the right. 1 times 2 only moves 1 unit to the right. So the amount that you're moving depends on how far you were from 0 with multiplication. With addition or subtraction, the amount of your movement does not depend on how far from 0 you are. You're going to move the same amount regardless of where you are relative to 0. So let's look at this Data sufficiency question. Which statement do you think is easier to evaluate? Yeah, absolutely. So statement 2 is easier to evaluate because just knowing the price of Q without knowing anything about P couldn't possibly be sufficient. Like, how can I tell which one is cheaper if I don't know the value of P? So we can go ahead and eliminate BD because those are the answer choices that claim that statement 2 is sufficient on its own. It's clearly not. Now, statement 1 on its own is interesting. It tells us that the difference between Q and P is less than 50. Now, would you say that statement 1 is describing a ratio? Or would you say that it's describing how far away from each other two things are on the number line?
How far they are away from.
That's right. It's talking about the distance on the number line between two numbers. And it's telling us that distance is less than 50. But we need to compare that to the distance that would result from a 6% sales tax. So how would the 6% sales tax applied to P, how would that impact the distance on the number line between P and Q? That's exactly right. As we said earlier, a percent change is something multiplicative. So when you add, and I really shouldn't use the word add, but when you add 6% to P, as Babar said, you're multiplying P by 1.06, but we just discussed earlier that the impact of multiplying in terms of movement up the number line depends on how far away from 0 you were to begin with. And we don't know how far away from 0 P was. So multiplying P by 1.06, I have no idea how much that would move the price up the number line. So I know that the difference in the prices is less than 50, but I don't know what the 6% sales tax would result in. It could result in just an extra dollar, or it could result in an extra $1 million. I have no idea what the impact of adding 6% would be on the number line. So you're right. You can say that the 6% sales tax will result in a movement up the number line to the right. And the reason we can say that is because we know that P is a positive number. If it were a negative number, then a 6% increase would move it down to the left on the number line. But we know that P is positive, so it will move to the right, but I have no idea how much to the right. The size of the movement, that's right, it will move to the right. So P after the sales tax, and so P times 1.06, will definitely be to the right of P. How far to the right? No idea. Therefore, I can't compare it to Q. I know Q is less than 50 to the right of P, but where is 1.06 P? To the left of Q or to the right of Q? I have no idea. And that's why we eliminate A. Alright, so now let's combine the statements. So what do we know now? We know that Q is exactly at 1150 on the number line. We know that P is pretty close to Q. It's to the left of Q. But it's not very far to the left of Q. We know that the distance between Q and P is less than 50. So P is somewhere in between 1100, to the right of 1100, I should say, and to the left of 1150. Exactly. P is greater than 1100. By the way, P could be 1,000,000, right? Because nobody told us that Q is greater than P. So Q minus P could be negative number, and P could be 1,000,000. But the inference that we can make when we combine these statements is that P is to the right of 1100. So now that we know that it's to the right of 1100, can we tell what a 6% sales tax would do in terms of movement on the number line?
It will make it a bigger number.
How much bigger though?
Just by 6, we cannot say. because we don't have definitive limit on it.
We have a lower limit though. If we know that P is
Yes.
at least 1100, then well, what's 6% of 1100? 6% of 1000 is 60. 6% of 100 is 6. So 6% of 1100 is 66.
66.
Which means that after the sales tax,
66.
we're definitely to the right of 1166. And we know that Q is 1150. So if you know that one of them is 1150 and the other one is more than 1166, can you tell which one is more expensive? We can tell which one is more expensive now. So since they're both starting at the same price, can we just call that starting price P? That's the closing price of 2001 for both stocks. So A closed at P in 2001 and B also closed at P in 2001. So far so good? Now they closed at different prices in 2002. So let's say that stock A closed at price A in 2002 and stock B closed at price B in 2002. And we know that A increased more than B, so A is greater than B. So A is greater than B. And stock A went from P to A, and stock B went from P to B. So far so good?
Sure.
What is this question asking? By what percent was the price increase of A? What was the price increase of A? That would be A minus P. That's what the increase was for stock A. By what percent was that greater than the price increase for stock B? What's the price increase for stock B? B minus P. You notice that I wrote this out as a ratio? Why did I write it out as a ratio? I mean, they're asking by what percent was this greater than that? Right? By what percent was one thing greater than another thing? And I wrote the two things as a ratio. Why do you think I did that? The reason I wrote it as a ratio is because we're looking at data sufficiency. So I don't actually have to find the percent difference or the percent change. I just need to know the stuff that I would need to know in order to calculate the percent change. As we learned earlier today, it's better to think of percent change as a ratio. Remember we had that example of something was 20% more than something else, and we thought of that as a ratio of 6 to 5. So if you know the ratio of two things, you could infer the percent change from one to the other, and vice versa. So if I can find the ratio of A minus P to B minus P, I would be able to figure out the percent change.
Yes.
For example, if we discover that the ratio is 5 to 4, that means that, well, what percent is 5 more than 4? It's an extra 25%. 5 is 25% greater than 4. So whatever that ratio is, we could infer the percent change. So because this is data sufficiency and I don't actually have to find what percent greater it was, it's much easier for me to think of it as just, well, what's the ratio of A minus P to B minus P?
But why not just do A's to B then?
Because if I find the ratio of A to B, that might not be enough to find the ratio of A minus P to B minus P. Think about that. If you know the ratio of two things, can you infer from that the ratio of each of those things minus some number? Well, let's look at an example, a simple example. Let's say that I have 3 times as much money as you, JD. Okay? Now we each buy an iPhone. We spend $1,000 each. What's the new ratio of my money to your money? We started at a ratio of 3 to 1. I had 3 times as much money as you. We each spent $1,000. What's the new ratio of my money to your money? For me and JD, do you know what our new ratio is? We started at 3 to 1. We each spent $1,000. Now do I have twice as much money as him? 5 times as much?
No.
We don't know.
We will have an equation 3x minus 1000 over
Correct.
x minus 1000.
Correct. And what is that?
X is a variable.
We don't know. Depends on x. You got it. Exactly, Babar. So that's my answer to JD when he was asking why not just look for the ratio of A to B. Knowing the ratio of A to B does not allow me to infer the ratio of A minus P to B minus P. So we actually need to find the ratio of A minus P to B minus P. Is that part clear? I want you to think of this in terms of a number line. Knowing the ratio between two tick marks on the number line, what that tells you is who's farther away from 0 and by what factor. It's twice as far from 0, thrice as far from 0, 5 times as far from 0, 40% farther from 0. It's talking about how far away they are from 0 relative to one another. Like who's farther and by what factor. If you're going to be subtracting something from each of them, that means you're bringing them closer to 0 by the same amount or by different amounts. In the second example, it doesn't matter. But you're bringing them closer to 0, assuming they're positive, right? And you're subtracting from both of them, so you're bringing them closer to 0. So in the new positions, how much farther is one from 0 than the other as a ratio? I don't know, because the minute you're moving them by a certain quantity to the left, the distances from 0 are going to change in a specific by a specific amount, but the ratio of those distances is now unknown. So if J is 3 times as far from 0 as A is, you see what I have there on the number line?
J is making 3 times more. Okay.
Now if we cut them both in half, what would be the ratio of J to A?
I think the difference will be cut by half.
No, I'm not talking about the difference between J and A. I'm talking about the ratio of J to A. The ratio of J to A currently is 3 to 1. Cut them in half, what will be the new ratio?
It's still 3 to 1.
Exactly. So as long as you're expanding or reducing a ratio by the same factor, the ratio won't change. In fact, we already know that from arithmetic. Right? We know that 2/8 is the same as 1/4. So you're just reducing or expanding a fraction, which doesn't actually change the value of that fraction. Now, going back to J and A, which have a ratio of 3 to 1, what if we subtract each by 1? So J minus 1 and A minus 1. How big of a deal is it to subtract 1 from each of them? Like, is 1 a big number in the context of J and A? Or is 1 a very small number? Like, how big of an impact will subtracting 1 have on the ratio of J to A? Exactly. It depends on their values. It depends on how far away from 0 they are. I mean, if they're in the billions, right? If the numbers are 2 billion and 6 billion, subtracting 1 won't really impact the ratio at all. I mean, it will slightly, but you won't feel it. On the other hand, if J is 3 and A is 1, and you're subtracting 1 from each of them, the new ratio would be 2 over 0, which is not even defined. So let's not use that example. Let's take 6 and 2. So if J is 6 and A is 2, and you subtract 1 from each, now the new ratio is 5 to 1. So you went from a ratio of 3 to 1 to 5 to 1 just by subtracting 1 from each. But if there were 6 billion and 2 billion, subtracting 1 would barely register in terms of changing the ratio. It still will be approximately 3 to 1. So this is why I say that knowing the ratio of A to B does not allow me to infer the ratio of A minus P to B minus P. And what this question is requiring us to find is the ratio of A minus P to B minus P. This part is A minus P, and this part is B minus P. Well, when they say the price increase of stock A, they're talking about an actual dollar amount increase. They're not talking about a percent increase. If they meant percent increase, they would have said it. Exactly. And this is data sufficiency. I don't actually care what the percent is. So if I can find the ratio, that's good enough. Statement 1 is just giving you the ratio of A to B. Because the closing price of A is what we defined as A. We call this A. And we call this B. So it's saying A to B is a ratio of 108 to 100. Or 54 to 50, or 27 to 25. So if you and I each make $1,000 and then we get raises, but the raise is not the same. And I'm not telling you what the raise is. Could be that the raises are kind of in the millions. So even though we were each making $1,000, now we each make, millions of dollars. Or maybe the raises were just a few dollars each. But it wasn't the same raise. One of us got a bigger raise than the other. So we started each at $1,000, but then we each got a different raise as a dollar amount.
Okay. Yeah, so now you're telling me the dollar amount is different, and you're telling me this new resulting, what we get after this raise is perhaps 27 to 25. I don't even know what your new salary is versus my new salary is.
That's right.
Also, I don't think I would know your dollar amount.
No. There's no way, because look, there's so many different ways to get to 27 to 25. Maybe now I make 2,700 and you make 2,500. So that means our raises mine was 1,700 and yours was 1,500. Those are our raises. Maybe now I make 27 billion and you make 25 billion. So my raise was whatever the difference is, or 26,999,999,000. And yours was a raise of 24,999,999,000. So, and in both cases, we ended up with a ratio of 27 to 25.
Right.
And then when you ask how big of a deal was the raise, if we ended up with 27 to 25, I don't know how big of a deal was the raise. Maybe the raise was just 1,700 and 1,500. Or maybe the raise was like 26,999,999,000 versus 24,999,999,000. So in those cases, the raises are a much bigger deal than in the first example.
Right. That makes sense. Yes.
So that's why knowing the ratio of A to B, which is what statement 1 is giving us, isn't sufficient to find the ratio of A minus P to B minus P, because we don't know how big of a deal the minus P is. How big of an impact will that have on our ratio? We don't know.
The question is asking how much percentage difference is the raise versus I get versus how much you get.
That's right.
Okay, yeah, that makes sense. It's much easier to visualize now with the form of a raise, perhaps.
Good.
Yeah.
Now, statement 2, you probably love that one because you kept wanting to think of the raise as a percent increase. Statement 2 gives you that.
Exactly. That was coloring my view of, okay, it has to be a percentage increase. It can't be a dollar.
Yeah, I mean, it could be represented as a percent increase, or it could be represented as a dollar amount. But in the question, they're asking it in terms of dollar amounts, the ratio of the dollar amounts of the raises. So knowing the percent increase of one of them, how could that be sufficient on its own?
Yeah, S2 is definitely out, and I can see why S1 is also out.
So we could say that statement 1 gives us this ratio.
Yep.
And we could say that statement 2 gives us this ratio.
Yeah.
And what we're trying to solve for is this ratio. So what I want you to do now is take a minute and play around with knowing the ratio of A to B and knowing the ratio of A to P. Think about creating inference columns, just like we did with the first question of the day. and see if you can somehow end up with the ratio that we're trying to find. Exactly. We can consolidate those two ratios, and theoretically we could find out the ratio of A to B to P. And if you have that, then you can also make an inference column for A minus P, and you could also make an inference column for B minus P. So it turns out that if you combine the statements, you can answer the question. The correct answer is C. The beauty of this data sufficiency question is we still don't know the actual values of anything, but we don't need to because they're not asking for any actual values, they're asking for a ratio. So all of the information that we have is in the world of ratios, but that's okay because they're only asking for a ratio.
Yeah, that is brutal.
You see, whether our starting points were $1,000 or $10,000 or $1 million wouldn't change the ratio of our raises. Because we're not interested in the raises themselves, we're just interested in the ratio of those raises. So it's kind of similar to how the distances on the number line get cut when you cut the tick marks by a certain factor. It's really just expanding and reducing again, just like the example earlier when we said 2/8 is the same as 1/4. That's kind of the reasoning behind why the actual numbers don't matter when you're looking for a ratio, because you can just expand everything by a certain factor or reduce everything by a certain factor, and that won't impact the ratios. And it's like this, look, 12 is what percent greater than 10?
20.
Good. And 120 is what percent greater than 100?
20%.
And 1200 is what percent greater than 1000?
20%.
Do you see it now?
Yeah, I can see it.
I'm just expanding the numbers by the same factor, and that will keep the ratio the same. Just like taking a quarter and expanding that by a factor of 2 will get you 2/8, which is the same as a quarter.